Okay, what if instead of just reflecting a point across a line or an axis, what if we reflected an entire line, the equation of an entire line? So what we can do is, first I graphed this line, y equals 3x plus 2. The y-intercept is 2, and the slope is 3, up 3 over 1. So I just graphed that line. So one method, what you could do is you could make a list of all of the points that lie on this line. So I have my y-intercept right here, 0, 2. I have this point up here, which was 1, 2, 3, 4, 5, 1, 5. And I have negative 1, negative 1. I can also find those points by plugging into a t-chart. So like if I plug 0 in for x, 3 times 0 is 0, plus 2 is 2. If I plug 1 in for x, 3 times 1 is 3, plus 2 is 5. If I plug negative 1 in for x, 3 times negative 1 is negative 3, plus 2 is negative 1. That's how I got those points without graphing them. So now that I have all of these points, now I can take all the individual points and reflect them across the x-axis, because I know how to do that. That's just changing the sign of the y-coordinate. So 0, 2 is going to become 0, negative 2. 1, 5 will become 1, negative 5. And negative 1 will become negative 1, positive 1. So now what I can do is I can find the new equation of the new line using these new points. So I could find the slope of the new line. So I'm going to use the first 2 points to find the slope. So negative 5 minus negative 2 over 1 minus 0. So negative 5 minus negative 2 is going to give me negative 3 over 1. So the new slope is negative 3. And then my new y-intercept is right here, 0, negative 2. So the equation of my new line, I'm going to call it y prime, because remember that little tick mark indicates that we've performed some sort of transformation. We've reflected it or translated it or something. So y prime is going to be negative 3x minus 2. So that's the long way to find the equation of a line if we reflect it over an axis. There's a short way. There's a shortcut. So if we think about, like, if we take any point x, y, and we reflect it over the x-axis, all we're going to do is change the y coordinate sign. So xy would become x negative y. So and that is true for every point. So what we can do is we can do that exact same change to the x and y in the equation. So the original x and original y in this equation would be like this x and this y. So if I'm going to reflect this across the x-axis, all I'm doing is I'm multiplying y by negative 1. So I'm going to multiply y by negative 1. So that would be negative y equals 3x plus 2. And now I just want to solve for y. So I'm going to divide everything by negative 1. So y is going to be negative 3x minus 2. So if you notice, I got the same equation for y prime. So you can take the individual points and reflect the individual points and then find the new equation of the line using the new points. Or you can think, if I'm going to reflect a line across the x-axis, if I'm reflecting something across the x-axis, all I'm doing is changing the y's from positive to negative or negative to positive. I'm changing the sign of the y coordinate. So if I just change the y in the equation from positive y to negative y, I have reflected that line across the x-axis, and then I would just solve for y. So one last method, technically I could just visually, graphically reflect this line across the x-axis point by point. If I reflect this y-intercept across the x-axis, it'll end up down here at 0, -2. If I reflect this 0.15 over the x-axis, it'll end up down here at 1, -5. And if I reflect this point -1, -1 over the x-axis, it'll end up here at -1, +1. So if you graph it, it's going to look like this, which if you're thinking about we're reflecting over this x-axis, it just went boop. What was below the x-axis is now above the x-axis. What was above the x-axis is now below the x-axis.